Hello viewers, my name is Brian Ambundo and this is Chopini Electrical Engineering. Today I want to introduce us to the most beautiful equation in mathematics, and it is the Euler's identity. The Euler's identity is written as e raised to power I pi plus 1 is equals to 0. So what is I? In the most simplest term, I is equals to square root of -1. It's an imaginary number. What is E? E can be written as a non-terminating decimal number, and it is shown as follows. Fourthly, we can see that we can write E as a series, and E in terms of a series is written as 1 plus 1 all over 1 factorial plus 1 all over 2 factorial plus 1 all over 3 factorial plus 1 all over 4 factorial. And then the series continues onwards up to 1 all over n factorial, where n is infinity. E can also be written as e raised to power 1. And if e is the same as e raised to power 1, then e raised to power x can be written as follows: 1 plus x all over 1 factorial plus x raised to power 2 all over 2 factorial plus x cubed all over 3 factorial plus x raised to power 4 all over 4 factorial, and it continues up to x raised to power n all over n factorial. Since we've seen how we can write e raised to power x, we can also express the sine wave in terms of a series. And this is how we express the sine wave in terms of a series. Sine x is equals to x all over 1 factorial minus x cubed all over 3 factorial plus x raised to power 5 all over 5 factorial minus x raised to power 7 all over 7 factorial, and the sequence continues. The same way, cos x can also be expressed in terms of a series, whereby we have cos x is equals to 1 minus x squared all over 2 factorial plus x raised to power 4 all over 4 factorial minus x raised to power 6 all over 6 factorial plus x raised to power 8 all over 8 factorial. Now, if you take a look, you notice that there seems to be a kind of relationship between e raised to power x, sine of x, and cos of x. What if we add cos of x and sine of x? Would it give us e of x? Let us try and see. So sine of x plus cos of x is equals to 1 plus x all over 1 factorial minus x squared all over 2 factorial minus x cubed all over 3 factorial plus x raised to power 4 all over 4 factorial plus x raised to power 5 all over 5 factorial, and the sequence continues. So as you can see, when we were dealing with e raised to power x, all the terms had a positive integer. When we were dealing with sine x, the negative and the positive terms were alternating. And as we were dealing with cos x, the negative and positive terms were alternating. by adding them together, we find that we start off with a positive term, followed by two negative terms, followed by two positive terms, followed by two negative terms. So there seems to be a disconnect between whatever we want to achieve and whatever we have. There is a way in which we can work around this. We can introduce a factor I in the equation cos x plus sin x. We end up getting the same equation as e raised to power x. So we can see that we have gotten something that is similar to whatever is the equation e raised to power x. The only difference is e raised to power x is multiplied by a factor I. If we were to write this in terms of cosine and sine, we will take the terms that are real and group them together, and the terms that are imaginary and group them together. So e raised to power x is equivalent to writing cos x plus I sin x. If we replace the value x with pi, we will get that e raised to power I pi is equals to cos pi plus I sin pi. Remember, pi is written in terms of radians. 2 pi radians gives us 360 degrees, hence a single pi radian is 180 degrees. If we look for cos pi, we will get it to be -1, and if we look for sine pi, we will get it to be 0. Hence, the equation is deduced to e I pi is equals to -1. This can also be written as e I pi plus 1 is equals to 0. And that is how we get the most beautiful equation in mathematics.